Hi there, now I'm going to show you how to make the final predictions on the test set. So in this project, again, the goal is to train a single layer neural network using keras, TensorFlow. And what we did last time is we computed this plot of the mean validation loss as a function of the number of training epochs, just like we've done in previous projects. Here it's the average over 10 um, 10 splits um, into 70% train and 30% validation. The best number of epochs on average was this epoch number 43. And so that says that we should use 43 epochs if we want to have good prediction error on our um, on our test data. And so going back to our code here, we have in our previous screencast, we first started out by downloading the spam data, converting it to this Y array, and then um, splitting it into this in the scaled X matrix, and then splitting it into train and test. So here we have X train mat, X test mat. We have Y train, Y test. So these are the things that we're going to be using now. So we're going to train on our whole training data now that we know what is the good number of epochs. So going down here, here's the code that we used to train our neural network. So here I'll do that. And here we have keras model sequential, layer flat, blah, blah, blah. Same size of neural network. The neural architecture doesn't change. But now, yeah, and also we're not going to change we're not going to change these compilation definitional loss or optimizer accuracy metric or anything like that. But we are going to change here in the fit call. Here they were using validation split equals 0.3. So now we're just going to use validation split equals 0. And let's see if that works, because what we want now is we want to train on the entire data, not the entire data set, the entire training set, not use any validation data. And here what we should do is we should set the number of epochs to be this best number of epochs. Here it was this min dt epoch. That's the best number of epochs that we saw so far. So here, let's run that code and see what it gives us. So here, notice that it's only showing the train loss and accuracy because we don't have any validation data. And as expected, the train loss always goes down. But now what do we want to do? We want to use this trained model on the test data. So remember we held out these X test and X train. Yeah, we made the split into X test and X train. And so what we can do, going back to the TensorFlow our tutorial, we have this function called evaluate. So let's do that. Let's evaluate and see what that gives us. And so if we do model evaluate, here I'm going to replace this with X test mat and then Y test. That should give us some measure of our loss and our accuracy with respect to the test set. So using this neural network, we got a loss value of 0.21. And that's a logistics loss, so that's not it's not a percent. But this accuracy here, this is the percent. This is the percent incorrect. It's a percent correctly predicted labels in the test set. So the test set, again, this Y test, this is a set of 921 921 binary labels, email messages, which are either spam or not. And so what this says is that of those 921 messages in the test set, we predicted 92.5% accurately. So is that good? What we have to do now is we have to compare that number to some baseline. So, I mean, a simple baseline is to just look at the training data and predict the same thing as the major class in the training data. So here, if we look at the training data, we see that there's around more than 2,000 zeros and only 1,400 ones. So the best class to predict, if we're using our baseline classifier here, is the 0 class. So let's programmatically define that. So let's call that y tab. And so, you know, we can do y tab which max y tab, and that's going to give us the biggest entry. Then we can use names here to get the label that's corresponding to that, and then we can use as integer to get an integer value. So let's call that our y baseline. And so, you know, to do an evaluation, here we can do evaluation x test map. So no, we're not going to use the model for evaluating. Now what we're just going to do is we're going to compute on the y test, how many y tests are equal to y baseline, because that's what that prediction, that's the accuracy rate on the test set for the baseline classifier. And so the baseline here is 61%. So we could get 61% accuracy just by guessing the most frequent class in this data set. Versus using the neural network, we can get up to 92.5% accuracy. So the neural network seems to be doing quite a bit better than just the guessing the most frequent class. Yeah, I mean, it's of course good if you can have a standard deviation for making that comparison. So we don't have any measure of you know, the variance of this quantity 0.92. Is there, you know, is the standard deviation 0.1 or is it 0.01 or whatever? You know, we don't know. So we don't know really if these two numbers are significantly different, but you know, they're quite large in terms of, you know, percentage points. So we can kind of suspect that the neural network is doing a good job here. Okay, so that's how you make the predictions using the neural network. We figured out what is the good number of epochs to use by looking at a validation set. Then we use that number of epochs on the entire train set by setting validation split equals 0, and then we use the resulting model on the entire test set. So we compared that against the baseline in terms of prediction accuracy, and we saw that, you know, the neural network is doing quite a bit better, 92 versus 60%. And you know, there's other metrics that we can maybe compute, such as area under the ROC curve, but I'll save that for another screencast. Thanks for listening.